Friends, today's topic is Sandwich Theorem or Squeeze Play Theorem for evaluating limits. The statement: let gx, fx and hx be three functions, okay, such that gx is less than or equal to fx, less than or equal to hx, okay, in the neighborhood of x is equal to a is a point in the domain, if limit x tends to a of gx is equal to L and limit x tends to a of hx is equal to L, then limit x tends to a of fx is equal to L. Again I state this one. Let gx, fx and hx be three functions such that gx less than or equal to fx, less than or equal to hx in the neighborhood of x is equal to a. A is a point in the domain. If we have been given that limit x tends to a of gx is equal to L and limit x tends to a of hx is equal to L, that is the same limiting value. So in combined, both of them will imply limit x tends to a of fx is equal to L. This is known as the Squeeze Play Theorem or Sandwich Theorem. If we plot this concept in graph, then it will be clear. Okay, first of all, you see that gx is less than or equal to fx, less than or equal to hx. So the graph is like this. Okay, gx is less than or equal to fx, less than or equal to hx, means if you take any value, say this point is c, okay, at the point c the height is this one, this is actually gc, and if you draw at this point x is equal to c, you will find another height and this height is equal to f of c. If you draw a height at the point x is equal to c up to this graph, then you will find another height, this is h of c, isn't it? So here gc is less than fc is less than hc. So we can say that gx is less than or equal to fx, less than or equal to hx. Now friends, see that at a particular point, so this point is x is equal to a, this point, okay. At this point, all the curves are squeezed, okay. At this point, x is equal to a, all the curves are squeezed, okay. So such that we are getting the height near about same. That means the value of the function at the point x is equal to a of y is equal to gx is this one, g of a, and the y is equal to fx, you will get f of a, and y is equal to hx, you will find h of a. But according to this statement, that is limit x tends to a of gx is equal to L, limit x tends to a of gx is equal to L, this height is equal to L, and limit x tends to a of the function y is equal to hx is also L if it happens, okay. That means g of a, limit x tends to a of gx and limit x tends to a of hx, both are of same height L, then since fx lies in between these two curves, so for this obviously the limiting value of the function y is equal to fx at the point x is equal to a must be L, isn't it? So we shall see an example to clarify this one. Okay friends, how to apply the sandwich theorem in a question? Okay, suppose it is asked to find limit x tends to a of fx. Okay, so squeeze this function fx in between two functions gx and hx such that gx is less than or equal to fx less than or equal to hx. Okay, we are just squeezing this fx in between other two functions gx and hx. Okay, so when we give a limit of this function gx, say we are giving a limit x tends to a and it is giving an output k. Okay, and similarly if we put another limit here, say same limit x tends to a and it is again giving the output k. Okay, since you are looking that both the limiting value are same, k and k here also, so obviously since fx is lying between gx and hx and this is squeezed here, so if you put the same limit, that means limit x tends to a, then obviously it will output k, isn't it? So we shall see an example here. Suppose a limit x tends to 0 of x into sine of 1 by x. Okay, what is the value of this one, limiting value? So it is obvious that limit x tends to 0 of x, and what will be the limit x tends to 0 of sine of 1 by x? Whatever you put here, sine of 1 by x or sine theta cannot be more than 1 or less than minus 1. That means it will lie between minus 1 and 1. That means 0 into a finite value. That means this is the result is 0, isn't it? Limit x tends to 0, x into sine of 1 by x is equal to 0. But if we want to apply the sandwich theorem here, what will happen? You see, we know that sine theta lies between minus 1 and 1, and here this is sine of 1 by x. So we can write sine of 1 by x lies between minus 1 and plus 1, isn't it? Okay, multiply each term by x. So we shall have minus x less than or equal to x sine of 1 by x less than or equal to x. Now we take the limit x tends to 0 of minus x less than or equal to limit x tends to 0 of x sine 1 by x, that is less than or equal to limit x tends to 0 of x, isn't it? So obviously it gives the output 0, isn't it? Limit x tends to 0 of minus x is equal to 0, and limit x tends to 0 of x is again 0. So see that both the limiting value are same. This is 0, this one is also 0, and this part is squeezed in between these two, and both of the limiting value are 0. Obviously it will give the output 0, isn't it? Limit x tends to 0 of x sine 1 by x will give you the limiting value 0. Okay, when is the sandwich theorem is not possible to apply? Suppose gx is less than or equal to fx less than or equal to hx. If you find that limit x tends to a of gx is equal to 1, okay, and limit x tends to a at the same point x tends to a of hx is equal to 2, okay, one limit is 1, another limit is 2, at the same point limit x tends to a, here also limit x tends to a, first limit is 1, second limit is 2. So what will be limit x tends to a of fx? Now friends, this will obviously lie between 1 and 2. 1 and 2 because the limit at the same point extends to a is 1 and the limit extends to a of hx is equal to 2 and fx is squeezed in between gx and hx. So obviously its limit when extends to a, it will give an output in between 1 and 2, isn't it? So we cannot write the exact limit of fx. That means its limit will lie between these two limiting values 1 and 2. Evaluate using sandwich theorem. Limit extends to infinity of x plus 7 sin x divided by minus 2x plus 13. We know that minus 1 less than or equal to sin x less than or equal to 1. So we can write, multiply each and every term by 7. So minus 7 less than or equal to 7 sin x less than or equal to 7, or x minus 7 less than or equal to x plus 7 sin x less than or equal to x plus 7. Now dividing throughout by minus 2x plus 13. Okay, why? Because in the denominator we have minus 2x plus 13. So what shall we get? X minus 7 divided by minus 2x plus 13. Okay, now the inequality sign will be changed. This will be greater than or equal to, why I shall discuss. X plus 7 sin x divided by minus 2x plus 13 is greater than or equal to x plus 7 divided by minus 2x plus 13 for all x that are large. Now see that what happens, x tends to infinity, x is tending to a large quantity. Okay, so minus 2 times of x, minus 2 times large number plus 13. Obviously this is a negative quantity. Minus 2x plus 13 will tend to a negative quantity, huge large negative quantity. Okay, so when you divide by a negative quantity in the inequation, so obviously the inequality sign will be changed, isn't it? Suppose I give an example, say minus 2 is less than 3, isn't it? Minus 2 is less than 3. So if you divide both sides by minus 1, what will happen? Minus 2 divided by minus 1, and this will be divided by minus 1. So minus 2 by minus 1 means plus 2, that is positive 2, and this is negative 3. So positive 2 is obviously greater than negative 3. For this, when we have divided each term by a negative huge number of negative term, then obviously the inequality sign, which was earlier less than or equal to, it will be converted to greater than or equal to signs. Okay, so x minus 7 divided by this and so on. Now we shall take the limit on the both sides, on the either sides. Okay, limit, what will happen if we take the limit here? Limit x tends to infinity, x minus 7 divided by minus 2x plus 13. It will be limit x tends to infinity, positive infinity, 1 minus 7 by x minus 2 plus 13 by x. Obviously if you put the limit here, you will find 1 divided by 1 minus 0 divided by minus 2 plus 0, that is equal to minus half. Okay, we have put the limit here, x tends to infinity. Again we put the limit here also on the extreme right. Okay, limit x tends to positive infinity, x plus 7 divided by minus 2x plus 13. Okay, so see that a limit x tends to positive infinity, this is 1 plus 7 by x minus 2 plus 13 by x. Okay, so this is 1 plus 0 divided by minus 2 plus 0. Why do I write 0 and 0 here? Because you see that x is tending to positive infinity, so 7 divided by a huge number of positive quantity, it will near about tend to 0. Similarly 13 by x also tending to 0. For these, the limiting value is tending to 1 divided by minus 2, isn't it? So the limit is minus 1 by 2. Now see that, friend, both the limits when x tends to positive infinity are same, minus half and minus half. And since this function is squeezed between these two other functions, so for this its limit, when you will put the limit x tends to a positive infinity, it will definitely give the output minus half, isn't it? So using the sandwich theorem, we found the limit x tends to positive infinity of x plus 7 sin x divided by minus 2x plus 13. This is equal to minus half. Thank you. Have a nice day.